Principles of Bioproduct Separation Module 4 Cell Disruption Segment 2 with me again Yusuf from Institut Teknologi Bandung. Previously we have discussed about cell membrane. In this segment we will discuss about chemical methods to disrupt cells. There are several chemical methods that can be used to disrupt cells. We will first discuss about enzyme digestion and alkali treatment. The disadvantage of enzyme digestion is high cost of enzymes which hinders their application in a large scale. Although enzymes are gentle and selective, we can add enzyme to a cell suspension which react quickly with the cell's wall and destroy them. Alkali treatment is the antithesis of enzyme digestion. It is cheap rather than expensive, harsh rather than gentle, non-selective rather than specific. High alkali concentrations required spark many degradations including protein denaturation. As a result, these methods tend to both rupture the cells and destroy products. Even though it is cheap, alkali treatment is less useful than other methods. Osmotic shock is a very simple method. We can add a given volume of cells into pure water, often about twice the volume of the cells. The cells swell because they contain solids which can cause an osmotic flow of water into the cells. In some cases, they swell so much that they burst. The contents are released into the surrounding solution which can then be separated. The susceptibility of cells to lysis depends strongly on their type. Red blood cells are easily lysed, whereas animal cells can often be lysed only after animal tissue has been mechanically minced or homogenized. Plant cells are much more difficult to lyse because they contain strong woody materials which is relatively impermeable to osmotic flow. The osmotic flow involved comes from the osmotic pressure, which is surprisingly large. To estimate the size of this pressure, we turn to the definition of chemical equilibrium, which states that the chemical potential of water must be constant as shown in equation 1. The corresponding potential at the inside involves a reference value, pressure correction, and a correction for solution concentration as shown in equation 2. If the cell's content are a dilute solution, equation 2 can be simplified and rearranged to form von Hauff's law as shown in equation 3. Hence, at equilibrium, the pressure outside the cell must be less than that inside. If not, water will flow into the cell and potentially lyse the cell wall. Solubilization. The second major method of chemically rupturing salts is solubilization by detergents. Typically, a concentrated detergent solution is added to about half the solution's volume of salts. The detergent disrupts cell membrane and the resulting suspension can be centrifuged to remove cell fragments. The chemistry depends on detergent structure as shown in this figure. The structure has a hydrophilic portion which is often ionic and a hydrophobic part which is frequently a hydrocarbon. As a result, the detergent is amphipathic, which is capable of interacting with both water and lipid. Typical detergent properties are shown in this figure, which change abruptly over a narrow range due to the formation of micelles, often called as a critical micelle concentration. Lipid dissolution. This method is important and simple but requires experiments. One of the solvents that can be used is toluene, which can be added to a cell suspension about equal to 10% of the biomass. The toluene is absorbed into the cell wall, swells the walls and ruptures the wall. Other solvents are also effective. Benzene works well but is carcinogenic and highly volatile. Chlorobenzenes are also effective. High alcohols like octanol is also effective. One good way in choosing solvent for experiments is to look at their solubility parameters. These parameters will reflect the solvent-lipid interactions. Solvents with similar solubility parameters should attack cells in a similar way. Ideally, we should choose solvents whose solubility parameters match those of the cell wall lipid, but far from those of the desired products locked within the cells. In the next module, we will discuss about mechanical methods. Until then, I am Yusuf from Institute Technology Bandung.